Hello, Toastmasters. Most welcome guests. We have more guests now, I think. I'm not Stephen Hawking, not at all. But today I want to tell you about such abstract physical concept as gravitational waves. It can be very difficult to perceive, and it could be easy if we speak about it in basic, easy words. Let me try to solve this mystery today in front of you, so by the end of my speech you understand better what it is, why they're here, and what effect they may bring to us. Something happened this year on February 11, 2016. The scientific society found out officially that the gravitational waves were recorded, and thus the theory of relativity by Einstein was proven. Let's look at this picture. This is something that happens very, very far in the outer space, somewhere in the universe. Two huge black holes curved and clashed 1.3 billion years away from our planet. And this clash caused the gravitational wave that was recorded on this planet just before this was announced in February. Let's take a look at this picture. You all know this person. He is the author of the theory of relativity. We all heard this, we all know this, but do we really know what relativity is and what effect it has on us in our life? Have you seen this movie? Raise your hands. This is the Interstellar movie. Do you remember what happened on this planet with these huge waves? They spent there only 2 minutes, while on the orbit in the spaceship, 40 years have passed. So the time in this space on the surface of the planet was moving faster than out there in the orbit. So this is the relativity of space and time, and it has an effect on us. What happened on this planet is closely connected to the concept of gravitation, or gravity if you want it, because gravitation is more scientific. Gravitation, as we know it from the school lessons, is something that makes this apple fall down on the earth. Why? Because our planet is bigger and the apple is smaller, and the mass of the planet attracts the smaller mass of an apple. If I throw it to Tanya, she will catch it because it will be falling on her because of the earth weight. What Einstein said is, you can see on this picture, if we put this apple on the flat sheet of clothes, it will push it down. And what happens next, if we put another apple on the side of this sheet, it will also go down, and it will not be attracted by an apple itself. The apple doesn't change the gravity. What apple does, it changes the space and time continuum around it, and it deforms the geometry of space and time. And this is something that happens to our planet while the satellites and the moon is going around the planet. The deformation of space and time, this is what gravity means. And Einstein said, not proved that yet, that massive objects, the objects that have mass, they weigh down space and time. That is why on our planet, time goes slower than on the orbit. So basically the cosmonaut has to do something with that clock when they come back to the Earth. This is what happens with the gravity thing. Now let's talk about waves, gravitational waves, 2 words. What is a wave? In very, very plain words, like school 5th grade, the wave is something created when we accelerate an object. Let's say we have a float, and when we start pushing it there and back, the waves will start moving on the surface of the pool. If we take a guitar string and start touching it, the acoustic waves will start moving and we'll hear the sound. If we take a particle, an electron, a small particle, and start moving it very quickly, the electromagnetic wave will start and we'll see the light. Now what happens with the objects with the mass when they move or collapse? They also emit waves, and they were called the gravitational waves. Einstein predicted the existence of gravitational waves exactly 101 years ago, but it hasn't been proved until recently. Now when I tell you the gravitational wave is something that any object with a mass can emit, meaning me. I'm an object with a mass. So do I emit gravitational waves when I move? Probably I do, right? Why don't we detect them? The reason is that the gravitational wave is so small and so weak that we cannot detect it by means of normal detectors. It's 10 billion trillion times weaker than an electromagnetic wave that a particle emits. You can imagine how difficult it is to detect such a wave. How it may feel if the wave is big enough. I will stretch and I will tighten so that what could have happened to all of us if we had lots of gravitational waves coming to the planet. Luckily, it doesn't happen. Why? Because only huge collisions of huge objects in space can emit such gravitational waves that go away from those objects, move through the space for a billion, trillion light years, and they change the space and time. They deform the geometry of this universe. This is a difficult concept to understand. The gravitational wave is something that was not proven and was not detected, and scientists even didn't know if they existed. They were looking for them for 100 years. Two black holes collapsing billion years away from here may emit gravitational waves that may reach our planet in many years, and we may detect this. How? I said it's very difficult. It's so weak. To do that, special detectors were created about 20-something years ago. This one is the LIGO detector in the USA. 2 lines of 4 kilometers long. It's quite a complex structure inside of it, with mirrors and vacuum and laser beams transferring from one point to another, trying to detect the smaller fluctuation. And if they find it here, this means the gravitational wave has been recorded and detected. This happens so rarely, so that they were looking for this for years, for decades. When finally, just a little before February 2016, they found this fluctuation. This was the collision of those 2 huge black holes, very far from our planet. This is how it happened. And this was a major discovery of almost 100 years since the theory of relativity was presented. They were looking for such proofs. This is the modeling of how 2 black holes are colliding together, emitting those waves that are changing the space and time around, the waves that travel through the universe to all objects in the universe, transmitting this knowledge. What does it mean for us? Gravitational waves. It's very difficult. Do we use it somehow in our daily life? Probably not in daily life. But lots of experts, scientists, and people pretty far from science, like Mark Zuckerberg, for instance, they say that this is the huge discovery of the century. The last point to prove in the theory of relativity, the thing that will bring us to the beginning of our universe, the God itself. So guys, if you got interested somehow in the concept of gravitational waves, I hope my talk was just a bit useful to you. And if you think you may want to dig deeper to the subject, just keep calm and do some science.